All right, so this video is going to show you guys how to create a line of best fit. Now, a line of best fit is basically an equation of a line that matches a table of data. So you can see over here on the left-hand side that we've got a table of data that we created. We were tracking the number of miles we ran. Maybe we're getting ready for a marathon. So you can see in week 1, we ran 1 mile. We ran 5 miles. In week 2, we ran 8 miles. So our first step is to actually create this table in our DESMOS calculator. So you've got your DESMOS calculator open over here on the right hand side. And to put that data into our calculator, we're going to start by pressing this plus button right here. So we press the plus button. It doesn't take a rocket scientist to figure out. We're going to click on table. So let's click table. And now we're just going to take these numbers and we're going to type them in. It's up to you how you want to type them in. With if you want to go hit the 1 and then go over and put in the 5, or you can just keep going down. So 2, enter, change that to a 4, type in a 6, type in an 8, type in a 10. So there are my x values. That's your week. So you're always going to put your x values, your first column, in the first column. So that's x1, 1, 2, 4, 6, 8, 10. Come back over here. Let's fill these in. So 8 miles for week 2, 13 miles for week 4, 15 miles, and 19 miles, and 20 miles. What I want you to notice, if you click and drag on your table here, you can see that it's actually plotting those points, right? Now notice that those points do not make a straight line. It's not a perfect straight line. So what we want to do is we want to create a line that best fits that data. We want to create a line that best fits that data. So to do that, what we're going to do is we're going to create an expression. So our second step, once you've got your table typed in, our second step is to click the plus sign again. And this time we're going to select expression. Now, that's going to automatically create a new line for us. And I might write it probably down here. So if you didn't want to click expression and you're already in the table, you can just click right there as well. You don't necessarily have to click the plus sign. You can just click in the next available box. So this is the most important part because it creates that line of best fit. And you can type it in with your keyboard. And so I want to show you how this works if you're going to type it in with your keyboard. But at the same time, I'm also going to show you how you could type it in using the on-screen keys as well. So the first thing we have to type in is we're going to try and create our equation as y equals mx plus b. But we don't want just any y. We want to use y1 because we're using these data points. So you can simply type on your keyboard the letter y and the number 1. And it automatically puts that 1 kind of on the bottom right-hand corner. It goes automatically down to the bottom. Now, if on the screen, you can do the same thing. Click Y, then click 1. It's going to do the same thing. So if you don't want to use your keyboard and you want to use your screen, you can click like so. Now, here's the most challenging part. The next character, the next symbol that we're going to type, we have to type we're just going to use the very non-fancy way of saying it. We're just going to call it a squiggly. Because what a squiggly line is it means approximate. It means that it's an approximation, which is what we're doing. We're trying to find the approximate line of best fit. Not the exact line, but the approximate line of best fit. So on your keyboard, you're going to press Shift, and then the very top key right underneath the escape key, the very top key, and you're going to get that symbol right there. Okay, so you're going to click the shift, you're going to press shift, then you're going to press the squiggly or the approximate key that's near the top left of your keyboard. I believe it's underneath the ABCs here. Actually, I'm not certain. I haven't looked for it. Yep, there it is. So if you didn't want to type it with your keyboard, you could simply click the ABC button and then click this button right here. That's your key right there. So once again, I clicked the ABC and then I clicked this squiggly approximate right there. Next, we're going to type M because we're trying to do mx plus b. So let's type the letter M because that's our slope. And again, we now want x. So we're going to type x, but we want x1. So we're going to press 1 just like we did last time. Now, if you don't want to use your keyboard, I'll go back and I'm just going to type in M, the letter M, then the letter X, and the number 1. It's going to automatically put that 1 down below. All right, we're almost there. Our last piece is to plug in the plus B, so I'm going to press Shift plus sign and the B value. Okay, so what we've now done is we have created an approximate line of best fit, and it automatically populates a bunch of information. And so these numbers down below are very, very important. You can see that it's giving us some statistics. We're going to talk about residuals later, so I'm not going to get to that now. And then the most important piece are the parameters. And these are your M value and your B value. It automatically just created your best slope possible and your best y-intercept possible. So our equation is now y equals 1.67123. That's our slope. That's my M value. X plus B. My B value is 4.69863. So this just approximated our best equation. So when we ask you to find the line of best fit, that's exactly what you need to do. You type in your table first. Then on the next line, you type in y1 is approximately squiggly line, m times x1 plus b. You have to type those values in. It's very important that you are able to type those letters into your DESMOS calculator. Okay, so that has now given us our equation. What you would write down on your piece of paper if you were trying to answer the question is you would write down, okay, my line of best fit is y equals 1.67. If we were going to approximate here, you're probably not going to write down all of those. So let's just round to the nearest hundredth. So 1.67x plus my b value. My b value would be, if we rounded, 4 point, the 8 rounds the 9, now 9 runs out to 70. So you can see that that black line and the red line are pretty much exactly on top of each other because they're the same line. So the red and the black are pretty much exactly on top of each other. And that's because that is your line of best fit. It best approximates the line that would go through as many of those points and fit those points as closely as possible. Okay? The last piece that I want to point out is this R value right here. Okay? So if we're looking at this R value, not the R squared, but this R value, this is what we're going to learn about in a few minutes. It's called the correlation coefficient. Your R value measures the relationship between the X and the Y. It measures how good of a relationship it is. And what you're going to learn is that the best relationship possible is either positive one or negative one. A positive or a negative one would be a surefire guarantee. It's actually completely perfect. So we're not completely perfect, but we are pretty close because the R value here is 0.97. So that R value is very, 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 very close to 1, which means that this black line that we've created is a very, very good representation of our data. It's not perfect, but it's very, very, very good. That's what we're measuring with the correlation coefficient. The R value tells us how good of a relationship it is. So those are the steps that we're going to follow. We're going to really make sure we understand how to create a line of best fit by first typing in our data. Once our data is typed in, we're then going to create our line of best fit by typing y1 is approximately the squiggly mx1 plus b. And that'll automatically give us the m value and the b value down below. There you go. That's your line of best fit. Best of luck.